Alright, always good when you've got a setup like this to break any of the forces up into vertical and horizontal components. So you can see that we've got this, I'll do it over here and see if this works for me. That's T1, and so I could break it into this nice horizontal and vertical component here, and we know that angle is 60, so this must be 60 as well. And then we've got a T2, so I'll break that up into this horizontal and this vertical component, and again this angle's 30, so this must be 32 as well. And then we've got, this is already a vertical component, and what's the force? Mass times gravity. Alright, so does it say to use gravity is 9.8? We will anyway. Alright. So 9.8 meters per second squared for gravity, unless they say otherwise. Sometimes they say to use 10. So if we look at that and just look at the horizontal components. So horizontally, what have we got? Remember, this is a pot plant, so it's hung up and it's staying still. So whatever's pulling to the left has to equal the same force that's pulling to the right in order for it to stay in the same position horizontally. So I didn't write them on, I'll write them on now. So some old tags, so this is sine 60, lots of T1s, and can't always hide, so this is cos 60, lots of T1s. So just, oh goodness, just using your right angle trick. So again, this will be sine 30, lots of T2s, so that portion of T2, and this will be cos 30 as a proportion of T2. Alright, so just breaking T2 up into its and T1 into the horizontal and vertical components. So horizontally, we've got this pull happening to the left, T1 cos 60, and it has to equal the pull to the right, which is T2 cos 30. Now cos 60 we know is root 3 on 2, so we've got root 3 on 2, and cos 60 is a half, not 30, sorry. So cos 60 is a half, so we've got T1 on 2. Cos 30 is root 3 on 2. Alright, that's better. Alright, they're both on 2, so if we just multiply both sides by 2, we get T1 equals root 3 T2, which is what we wanted to get. Now, if we look then vertically, so vertically the ups have to match the downs if it's not moving at all. So upwards we've got T1 sine 60, and we've also got T2 heading up sine 30. And then downwards, so we could put minus here, or you can put equals. You just put it on the other side. So my downwards is my mg. Alright, so they're all the vertical components. So again, sine 60 here, we've got root 3 on 2 T1s. Sine 30 is a half, so we've got T2 on 2, and that's mg. And so we're going to end up with root 3 T1 plus T2, multiplying everything by 2, is 2 mg. Now, if I take g to be 9.8, that would be 2, no, I'll just write it, 2 mg. We'll do it in a second, but or I'll do it here. So 2g would be 2 lots of 9.8, so that would be 19.6. And we still have m there. So what we have is two equations, both with T1, so two unknowns. So let's say that's equation 1, that's equation 2. Right, we've got that. So if we want to find m, we are solving, so there are actually 3 unknowns, except they've become 2 unknowns because it gives us that T2 is 98 newtons. So we can sub that in straight away, or we can say, I'm going to put 1 into 2 and use the fact that T2 is 98, sorry. So subbing 1 into 2, I now have root 3 lots of T1s, and T1 is root 3 T2 from equation 1. And then I've got another T2, and it equals 19.6 m's. Alright, so if I factorise by T2 here, I've got root 3 times root 3 is 3 plus 1 equals 19.6 m's. Now T2 is 98, so I've got 98 times 4, and I might divide by 19.6 while I'm there to get my M. Alright, so put that in the calculator. 98 times 4 divided by 19.16, we'll get 20, and the mass is in kilograms. So find the mass of the flower pot. The mass of the flower pot is 20 kilograms. So breaking everything up into vertical and horizontal components, very handy.